Okay, we're going to go through this example, and we're going to talk about solving a problem where you have to make a list and you have to combine things. Okay? We're going to talk about problems like this where you have a number of pieces or a number of teams or a number of choices, and you're trying to figure out how many combinations can I make. Okay? Like in this example, you're going to combine two lengths of rope. It says at camp, each group of campers are given pieces of rope that measure 4 feet, 6 feet, 9 feet, and 10 feet. If you're allowed to tie two pieces of rope together to make a longer piece, how many different lengths could you make? We're going to tie the ends together, or connect them at the ends, okay? So we're going to discount the fact that you might use some of the rope to tie the knot. Let's just put the ends together so that we can figure out about how many different lengths of rope can we make. And it says to use a rectangular array. So I want you to highlight that word, a rectangular array. What a rectangular array is, it's kind of like a chart. It's kind of like your multiplication chart, where you have numbers at the top and numbers on the sides. And when you combine them, you make a number. You make a combination of the two numbers. So, here's how you set it up. 4 feet, 6 feet, 9 feet, and 10 feet, right? So draw that on the side. Write that on the side.
Nope.
Of your notes. Follow along. Come on, guys. We're going to use those numbers in our combination. And then across the top, above the numbers, don't write it on that same row, but above the row, write those same numbers, 4 feet, 6 feet, 9 feet, and 10 feet. Because we're going to combine these numbers. Okay? So, if you are working with another group, you could combine the two 4-foot pieces to make an 8-foot. You could combine the 4-foot and the 6-foot to make 10 feet. You could combine the 4-foot with the 9-foot to make 13 feet. And you could combine the 4-foot with the 10-foot to make 14 feet, right? And so what we've done is we've combined them in an organized way to so that we can see that we've used all the choices. All right? Then you can continue the pattern. 10, 13, 14. What do you notice about these numbers? 10, 8, 10, 13, 14, 8, 10, 13, 14.
It's always 4 numbers higher than the number on the outside of the box.
Okay, but if we're looking for combinations, can we count these twice?
No.
No, not if we're looking for different combinations. So what we have to do is we have to recognize, oh, I've already used these numbers. I can't use these again. I can't count these twice, because that's not a combination. All right? We can only count them once. But you can combine 6 and 6 to make a 12-foot. We haven't made a 12-foot yet. We can combine a 6 and a 9-foot to make a piece that's 15 feet and 16 feet, right? And then what? we keep going,
Yeah.
right? 9 and 6 is 15, but we've already got a 15-foot piece. 9 and 9 is 18. 9 and 10 is 19. Yep. Then, we've already made this row. 16. Have we made a 16-foot piece yet? Yeah. Have we made a 19-foot piece yet? Yeah. And we can make a 20-foot. Right? So let's go back now and reread the question. Make sure we answer the right correct question. Because you can answer a lot of questions with this information. We have to answer the right question. If they are allowed to tie two pieces together, how many different lengths can we make? Does it say what's the longest we would make?
No.
Or the shortest? How many different lengths can we make? Jacob?
Oh, you can make 4 different lengths.
4 different lengths?
Oh no, sorry, 5.
Well, let's count them. We can make an 8-foot,
Yeah. Oh.
a 10-foot, a 13, a 14, a 12, a 15, a 16, an 18, a 19, and a 20, right? Oh, okay. You forget about this?
Yes.
All right. So, how many different lengths could we make? Kaden? 10? 2, 4, 6, 8, 10. Yep. 10 different lengths. Not 10 feet, right? That's where it's critical that you go back and look. You might see, oh, feet, that must mean 10 feet. No, that's not what we're asking, or that's not what the question is asking. It's asking for how many different combinations can you make. And this is a really good way to organize when you're trying to put 2 pairs together, or 2 groups together to make a pair. All right? There's other kind of combination problems, though. And go to your book. Open up your book to lesson 3.5. Page 100. Number 5 is just like the one we just did. And so I'm going to let you do that one for homework. I want you to skip to number 6 because I know you've all been at a restaurant before.
Yep.
And at a restaurant there's lots of choices.
So, what are we doing? Just 5 and 6?
So if you were up at the counter and you were curious, I wonder how many different combinations I could make. Look at that menu. At the Lakeside Camp menu, you can get 2 main dishes, you can get 4 different kinds of salad, and 5 different drinks. Right? Now, we couldn't make an array to make pairs. It's not going to be that simple. How many different combinations, it says in number 6, how many different combinations of main dishes, salad, and drinks could you make? So skipping the dessert, yep. Now, to make this one, a way to draw this out is called a web, where you start with one combination, or one choice. Let's start with baked chicken. We know we can make catfish, or choose catfish also. But let's just use the baked chicken for example. Let's say you choose the baked chicken. Okay? Is that you?
No, it's not there.
Oh, okay. The baked chicken and the salad. So if we were to combine baked chicken and salad, what kinds of salad could we get with the baked chicken? What does it give us? A tossed salad. We'll use T for tossed. What else? What other kinds of salad are there? Coleslaw. Coleslaw. What's CS for coleslaw? Potato salad. And Caesar salad. C for Caesar. Okay. So with the baked chicken, I can get 4 kinds of salad, right? And let's say that I like the coleslaw. That sounds yummy. What kinds of drinks could I get with the coleslaw and the baked chicken?
Milk.
Milk. And Maya?
Apple juice.
Apple juice. What else? Jacob?
Chocolate milk.
Chocolate milk.
Yum, yum.
Sophie?
Punch.
Punch. And Grace?
Grape juice.
And grape juice? Yep.
Grape juice.
Yep. Good. So for each main dish, I could get a combination of 4 salads, and with that, I could also get 5 choices of drink, right?
Mm-hmm.
So how many choices would I have total just for the baked chicken? Since I could get baked chicken with 1, 2, 3, 4 choices, these combinations, there's 1 times 4 for 4 choices. And with each of the 4 choices, I can get another, I can't do a 5 and hold my pen. 5 choices.
So you get, you have to multiply 1 times 4. But
Yeah, which is 20. So just for the baked chicken, there are 20 choices, right? What if there are 2 main dishes then? There's baked chicken and there's catfish.
21.
Well, no. Could I get catfish with the tossed salad?
42.
And wouldn't all of these same choices be with the other main dish?
42.
Andrew?
42?
42.
No, 40. Right?
Which one?
What?
You said 42, no 40. Which one is it? 40, why?
Because you just add 20 and 20.
Yeah, there are 20 choices for each main dish, isn't there? So a total of 40 choices. Right? And I can see that I have all of the combinations listed. I didn't draw them out for each one, but I know that I can have 5 drinks with this one, 5 drinks with this one, this one, and this one. Alright, and this is called a web. It helps you to figure out and make sure that you have included all the different choices. Okay? So, those are 2 different ways to draw out a combination problem. If you have just 2 choices, what's a better way? To make what? Krista? A chart. Yeah, it's called an array. Okay? If you have more than 2 choices, then you can make a web. Yep. Any questions?
No.
So you're going to do 5 and 7
Okay.
for tomorrow, using those 2 ways of drawing them out. Do number 5 and 7.